This is Unit 7, Lesson 3. We're going to be learning about something called logarithms, which is a big, important part of this chapter. Everything we've done so far has been exponentials. So this right here in our first box, it is just another way of writing exponents. Okay, so this is what we call the logarithmic form. And it says here, we read this as log base b of a equals x. So really, it's like this missing power that we're searching for. And we'll talk about that more as we look through these examples on the first page. So this logarithmic form is the exact same as this exponential form. This b becomes the base in our exponential form. This x turns into the exponent, and it's equal to this a right here. So whenever you see these two things right here, they are interchangeable. So on the whole first page, all we're going to be doing is practicing converting back and forth between log and exponential form. So this first section, we're going to be starting in logarithmic form, converting to exponential form, and then vice versa in the next section. So we're going to do the odds on this page. So first one right here. If you guys look at this, so this is log base b of a is equal to x. So in exponential form, b is this base right here. So that means for number 1, 3 becomes the base. And then the exponent is this x right here. So that's this 2. So we write that up here as an exponent. And then equals a, which is whatever is right here. And for this problem, that's the 9. So write the 9. These ones are a little bit easier because what you end up with, you should be able to like fact check it and say like, oh yeah, 3 squared is equal to 9, so I must have converted that correctly. If you convert it any other way, like say you ended up with like 9 to the third is equal to 2, you should be slightly concerned about that because 9 to the third is not equal to 2. All right, so let's do these ones as well. This little subscript right here becomes your base. We call it the base when it's in logarithmic form. We call it the base when it's in exponential form. The free floating number over here turns into your exponent. Equals, and then this middle number right here is like your answer. And again, fact check it. 7 to the 0 is equal to 1, because anything to the 0 is equal to 1. And one more of these. This little subscript becomes your base. The number on the other side here becomes your exponent, and it equals this number, the middle number right here. And this is true as well. 4 to the negative second, we just talked about a lot of these in the last lesson. The negative exponent flips, so 4 squared is 16. The negative is what flips it into a fraction. So I want to kind of show you how you would read these, thinking of it in exponential form, and this will help on the back page. So log base 3 of 9. I want you to think of a log. Every time you see the word log, I want you to think of that as a missing power, okay? So think of this. What missing power of 3 gives me 9, and that's 2. For this one, what missing power of 7 gives me 1, and that's 0. And for this one, what missing power of 4 gives me 1/16, and that's -2. So that should hopefully be helpful in our next page. For now, we're going to go the opposite direction, converting from exponential into log. So right now we are in this form right here, and we need to turn it into this form. So going into logarithmic form means that we always start with the word log. The base from our exponential form turns into this little subscript, which is the base for our logarithmic form. So little 14 becomes the base here. And then the a goes over here. So that's the 196. The 196 goes right here. And then equals, and then the other number. So the number that was up here in the exponential form ends up on the right-hand side in the logarithmic form. So that is 2. So read it the same way I was reading these. What power of 14 gives me 196? A power of 2. Okay, so let's try this one. Always start with the word log. This 12 gets written right here. This 12 gets written right here. So you can follow kind of the same order. The 14 went here, the 196 went here. Equals, and then that 1 goes right here. So this reads as what power of 12 gives me 12, and that would be a power of 1. All right, one last one of these. Start with the word log. The 2 gets written as a subscript, it's like a base. The 1/8 gets written next, equals, and then the -3 goes on its other side. What power of 2 gives me 1/8? A power of -3. So that's just the converting. That should be a pretty straightforward thing. Once you guys start to see that pattern, you can work back and forth. On the next page, we are going to practice evaluating some of these. And these just really require you to know your powers, know what they look like when they're negative, positive, everything like that. So we do need to learn really quickly something called a common log. If something has log base 10, we call that the common log. This is the one that every calculator has, even those little scientific ones, even your phone calculator has a common log. So we just write this as just log of 10. So anytime you don't see the base, it's kind of like with radicals. If you don't write the index, you assume that it's 2 and you assume that it's a square root. So for this one, if you don't write the base, you assume that it's 10 and you assume that it's a common log. All right, so that'll pop up in some of these. So we are kind of bouncing around on this page. First one we're going to do is number 14. So this one, log base 3 of 27. Again, I want you thinking, what power of 3 gives me 27? So if you can just think it out in your head, that's fine. Or if you want to make a little equation like this, what power of 3 gives me 27? And that would be the third power. 3 to the third gives me 27. So this answer would be 3. So log base 3 of 27 is equal to 3. Let's do the one right underneath it. Log base 12 of 1. So what power of 12 equals 1? So what power of 12 equals 1? And again, this just requires knowledge of exponents, really. To give us 1, the only possible exponent this could be is a 0. All right, so it must be x equals 0. Let's do number 17. Log base 2 of 64. What power of 2 equals 64? So to translate, what power of 2 gives us 64? You might not know this one, but let's count through some powers. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. And 2 to the sixth is 64. So that missing exponent, that missing power would be 6. Let's do 19 and 20 in this section right here. So 19, log base 9 of 1 over 81 means what power of 9 equals 1 over 81? So what power of 9 equals 1 over 81? So here's something we should know from the last couple lessons. If you see a fraction like this, we should know that the exponent is going to be negative. All right, if we see a fraction like this, we should know that the exponent is going to be negative. So we know that for sure. And then for the number itself, 9 squared gives us just 81. So the 1 over 81 would be still the second power for the whole squared thing, but then the negative is what flips it. So negative 2 is my exponent that I'm searching for. And one more here. Let's do number 20. 64. What power of 64 gives me 4? So 64 to some power is equal to 4. These are probably the trickiest ones. So in order for this number to get smaller, I don't actually raise it to a power. I want to take a root. So this is back to our last unit, unit 6. So 64, what we know here is the connection is that the cubed root of 64 is 4. Because we know that 4 to the third gives us 64. So to go backwards, it's actually 1/3. Remember, 1/3 represents the cube root. We have like 1/2 represents the square root, 1/3 represents the cube root, etc. So this 4 to the third is equal to 64, which means 64 to the 1/3 is equal to 4, if you're taking that backwards. So a little practice with those. You guys will get quicker the more of these that you practice and the more familiar you are with your powers. So it'd be a good idea to brush up if you were looking at some of these like, oh, I didn't know that, 3 to the third power was 27. All right, one last category here, the change of base formula. This is a really important idea here. No matter what calculator you are working with, it will have a base 10 log. It will have a common log button. It probably doesn't have a log 16. It probably doesn't have a log 8, but it does have a common log. So here's a little formula. Anytime you need this, log base b of a, what you do is you take the common log of a and you divide it by the common log of b. Now the positioning of a and b is very important because with division the order matters. So let's do these odd ones here. Number 21, log base 16 of 64. Think like 16 to what power is equal to 64. And that's not something that comes out nice and neat. So if you don't know it, we could do the change of base formula. We could plug things into our calculator. So it's the common log of 64 divided by the common log of 16. Now you can do this in Desmos. You can do this on just like your phone calculator, whatever calculator you're using, any sort of scientific calculator. So I'm just gonna pull up in Desmos on my phone so I don't have to try to make my iPad do it. Turn. It doesn't want to turn. All right, let's just do it this way then. So log of 64, the log would be over in the little functions over here. I think probably in miscellaneous. So there's a log. So we do log of 64 divided by log of 16. So that ends up being 1.5. So that is our answer here. 1.5. So not a nice, neat one that we could have come up with in our head like this. All right, we're going to do 2 more to finish off this set of notes. So 23, log base 2 of 54 means 2 to what power gives me 54. So if we were trying to think through it the way we did on the top half of the page, we're not going to find anything because 54 is not a power of 2. I want you to think through some logic here. So 2 to the 6th power gives you 64. So this answer has to be smaller than 6. But if we go back to the last integer, that'd be 5. We know that 2 to the 5th is 32. So it's going to be a decimal. It's going to be somewhere between 5 and 6 because 2 to the 5th is 32, which is smaller. 2 to the 6th is 64, which is bigger. So our answer is going to be somewhere between 5 and 6. So we'll do this formula to figure out what it is. So we do the common log of 54 divided by the common log of 2. Now notice these, you cannot reduce these down, you can't cancel out the logs, and you can't do log of 54 over 2. It actually has to be a log over another log, otherwise your computations will come out all wrong. So I'm just going to change the one I had already. So make this a 2, and the one in the numerator was a 54. So just like I was saying, this is bigger than 5, smaller than 6. We always want 4 decimal places. So 5.7549. 5.7549. Okay, so 4 decimal places if you do this, if it's not nice and neat like this one. All right, one final problem here. Log base 4 of 136. So what this is asking you is 4 to what power gives you 136. So now we know that 4 to the 3rd is 64. We talked about this up here. 4 to the 3rd is 64, so this is going to be bigger than 3. 4 to the 4th, you might not know, but 4 to the 4th is 256. So that's bigger. So our exponent that we're expecting will be somewhere between 3 and 4. So let's set this up to find out. Common log of 136 over the common log of 4. You cannot reduce these. You cannot cancel the logs. You have to make sure that there's a separate log written for each. All right, so this should be 136, and this should be 4, right? Yeah, 4. All right, so again, between 3 and 4, so 3.5437. All right, so that is our introduction to logs.